hardware manipulators. And then we talk about like what if we don't have a physical board with us? What we are going to do, then we can use some simulator. So ROS actually provide that as well. So I'm going to talk about that. And I hope like most of you have heard about Kinect. So we are going to use this Kinect from Microsoft a lot in this in ROS and in this projects which Hong Kong actually talked about. And then our robot is like Turtlebot. ROS actually provides two robots. Like one is PR2, that's the big one with hands, and this one which we are going to use is a small one, but is quite handy because you can do a lot of things on that. We have some videos and you can see. And then I will shift to the programming concepts. I put it at the end because, like, you know, some people don't like programming at the start, so just get the basic picture what the things are, and then we will dip into that thing and see like what happens. And some of the libraries like OpenCV is quite familiar with you, I believe, if you have done the computer vision course. So then PCL, so how we can integrate these powerful libraries into this infrastructure of this ROS thing. And then the conclusion, so I just draw a picture here, and for us, like, it looks very easy. Like if I have to move from this place to some other place, I can easily avoid the obstacles. But for robots, this thing is not easy because they have to sense, and then there is some program which is running, which is deciding, can be based upon AI, can be just based upon some basic sensors, and then that decides like where to move. So in all these course, like in this course, we have given you some project and we ask you to do that thing. So you can put your own ideas into that and can write your programs. But the basic framework on which you're writing the programs is ROS. So, like, once we talk about robotics yesterday, like the previous times, we see robots, very big ones like robotic arms, which are still used in the industry, of course. But what happens is that, like nowadays, all the robots become so accessible. Like people in the universities, everyone is working on them. So here is some of the examples. Like on top left is PR2 from ROS and the Neo, and on the right bottom there is this Turtlebot which we are going to use. And in my next slides I'm going to talk about that as well. But the thing is that once these kind of things become so common, so everyone thought about like it's very, very difficult to like have an infrastructure for everything differently. Right? If I want to work on aerial vehicles and Turtlebot, let's say, so what I need to do? Like I can't be like mastering like assembly language and then I move to some other another hardware language. Very difficult. So there should be one platform. So everyone, like the guys previously thought about this and they make a framework that is called ROS. So let's define what is ROS. It's an open source, good news for those who want to do development, and reinventing the wheel is not a good idea, but here you can use the code previously. So it's basically a software framework. And why they call it robot operating system? Because it provides you all those things which you need. So hardware, actually, in our computers, we have this hardware. So operating system is actually providing all scheduling, everything. So ROS is doing the same thing. But on the other side, it is providing you a layer, 3 layers. One is the hardware layer, in which your physical robots are there. And then there's this basic ROS, which you might not need to like change because there are some drivers in there. So it actually gets the data and provide it to you. And then there comes an upper layer where you can develop your applications. So just think from the perspective like how the life is so much easy with that. Like you can just use this framework and you can write your programs. Like if I tell you like this is information and you don't need to worry about how that information is coming, it's very handy in robotics because in robotics, the drivers, the hardware get messy as you go inside of that. So the basic in ROS, there are 2 sides. One is the operating system side and the other is this packages, this applications. And here we have given the term of, for the application packages, so they are similar. So like after completion of 3 years, this is some of the demonstrations which ROS has provided. Like the framework is running and they can play music. I can open the actually these speakers as well. It's okay. So you can see like you can cook as well, like this, and you can have a hi-fi as well. You can move in the buildings. So it's not a magic actually. It's all people in the universities are doing this thing. The basic framework they are using is ROS. So they provided you some image processing, like black boxes. You can use them and you can get the information out of it. And this is one of the demonstration from MIT guys, and this is from the University of something like that. So they intend to show in this thing like it's real time as well. It's not like you just put this thing and you can say like, oh, it's not real time, it's close to real time. So this is one of the examples like where they say that you can recognize different objects. And this is how like if you, this went very quickly, but there is exponential growth in the packages, the application which people are developing. So this is till 2011, but now 2012 can be like, oh, so can open everything. So might be like within 5 or 6 years you will see these things in your home, and it might be you are the ones who actually develop some of the programs in that. So you can play with the lift as well. So I won't spend much time on this. You can see this thing on YouTube. So many things. This is just a motivation for you. But the actual motivation is like the marks thing. You see, like for the students, it's always like the marks. So if you are attentive enough in this presentation, you can get 8 marks easily, because I'm going to discuss some of the coding things, which is your warm-up project. So if you are attentive enough, like the guys, I believe if they are listen with care, they can do it tonight as well if they want. So let's talk about, like, of course, like in Windows we talk about versions. Here we also have versions. They call it distributions. So it's initially started in from Stanford, but then taken over by Willow Garage. It's a very familiar company or research institute. What they did is they started it from like 2008, and they have some different versions like Sea Turtle they call it, Diamond, Pack, Electric, and Ferde. This is the new actually version. But when I was seeing these logos, I thought about like, they started it from C, then they start flying, then their turtle become like, you see, and then at the end they are carrying this whole world. So the concept is there, like where they are heading. So we have one to Mars, and they might next logo will be like that. So what we recommend, the important thing is we recommend like you should use ROS Electric if you want to use your own laptop. So I will describe how you will use your own laptop as well. But the recommendation is ROS Electric, and ROS Electric actually has this thing like it won't run on the latest Ubuntu version because there is a conflict of libraries. So what we recommend are the 2 versions of Ubuntu 10.04 or 11.04. So you can go through these slides again and again, but just remember this is a recommendation. So why ROS? There's a big story, like I told you, like it's a open source, you can use the code. What actually we write in, like it's C++ or Python, so if you know any one of them, you can write your programs very easily. And scalable, like as I told you, like you have seen so many things, you can extend it to like large distributed networks and distributed environments. And of course, big community and continuous support is provided by Willow Garage. So here are the packages which are there already in this ROS. OpenCV is quite familiar. You can do image processing with that. There is one that is Eigen. Eigen is well known for matrix manipulation if you have done algebra or something like that. So Eigen is very familiar. Then Gazebo. Gazebo is a simulator. It's actually these entities are like not a part of, but now they have become a part of this ROS system because this has become a major hit nowadays. And then DC and some other packages are like you can say the software itself. So what are the goals and highlights? So it's like a distributed framework. So when we talk about distributed framework, it means like it's not centralized. So it's working on different applications at different nodes, different entities, and they are loosely coupled. So you don't have to, actually it's not, you can say it's not sequential, it's not running on one computer, it can run on multiple computers and can provide information within each node. The good thing about this thing is that, like, as I told earlier, like, device drivers and algorithms are already available. So you don't have to put an effort on this and that part. So that was like the basic motivation, like what ROS is, how it become it, and like what is there in that. But now, like come to the actual system, like how it looks like. So there are some definitions. If you understand those definitions, it will be very handy because this is mostly used. So packages are like the applications. Like we write some program, that is, they call it package. So you make a package of something. Like I make a package of reading some wheel information from the report, let's say. So that package is actually application. Whereas the manifest, they call it, it's like what are the dependencies of that program. So I write some program, and in ROS I use this dependencies. So that actually provides you that. And combination of some packages is called stack. So if you have two packages and you can build one big package out of it, and that they call it stack. And then there is of course stack manifest as well, same as like the previous one, describing the dependencies, like what kind of libraries we use. Let's say I use OpenCV, so this file will be describing that thing. So this is a overview of file system, what the file system looks like. Here's some picture as well, like if you can see, like the top on the common is like, it's a stack, and it contains two packages, like DFL and HNDF. So there in the stack, there will be like more than one package. If there's one package, you won't call it stack. So this is kind of a file system, like once we write something, we make a folder and do something with that. So here, once you want to make a package, want to make an application, so it will make a folder, and in that it will put those manifest files into that as well. And you can see some manifest files like this thing as well. So the architecture is like, it's a distributed or a graph-based architecture. Like in this picture, you can see some of the nodes, and there is some one node which is red one. So can anybody tell me, like, why I need this red one? Like the yellow ones, if the yellow ones are some, let's say some programs running on some reports or something like that. So why I need this red one? Why I connected every node?
To coordinate?
Yeah, to coordinate, of course. So that is like they need some coordination, and then you need some central, or not a central processing thing, but it is like the way from where you go through, like it's a master. So they provided a distributed kind of a, you can say an idea, and then on that they provided a concept of node, like there are some applications nodes running, and then there is one master which is like a parameter server or something which is coordinating with every node in that. And once a node has to talk to some other node, so node is here the application, right? So if it has to talk to another node, so it needs to send some information. So information can be sent in two ways. One is message, and the other is service. I will describe what that thing is. So what I'm actually delivering here is a lecture, so I'm conveying some messages, right? So I am conveying, I'm a node here actually, and you are also nodes. So I'm communicating through an environment that can be like master server. So I'm sending some messages. So here the concept is same. They're sending some messages, and services is that like it's information plus you want that response. Like you ask the other node to give you that response. It's not like you just give them information. You want the response in that as well. Here the node, as I told you previously, it's an agent communicating with the main master node or ROS node, and it communicates via two ways, like topics. Topics are the messages, and so messages are like that, like you are listening me, so you are subscribed to me, like you are listening to But the people who are outside, they are not subscribed, so they are not listening to me. There are also nodes, but they are not listening. So you have a chart, like if you want to go outside, you can like go outside, and this subscription will be void, right? Whereas in the service, I will ask a question and I expect some response from you as well. So it's like that, I ask you a question and I expect like any answer, like 1 plus 1 is here 2. So it's a response, so he has to give me. And message is like he's listening to me and like, this is some other space thing. So this is a very minor difference, or major difference you can say, but this is how like you can communicate between the two packages. So a more description of what nodes are. Node are processes. So I might like is reiterating all those things again and again. So like once you read these things, you will get a very good idea of what I'm talking about. So nodes are processes that perform the computation. So it's basically designed like in a modular way, so in a distributed way. And each node is using its own library and its own dependency things within that. So master is the one which is actually communicating between different nodes. And what about the messages? Now, what kind of messages can be in the programming? So, like if I want to send a number to, like just a number, like I am a node, I'm computing something, like I have a camera and I'm looking at something and I'm counting that like item. So I'm counting like 1, 2, 3, 4, and I have to send information to some other node or to some other program. So what message I will give to him? So if my numbers are within like integers range, so I will send that message in the integer form. So, and then that program can send the information to some other nodes. It's up to that. It's most like C structures kind of a thing. And topic is just a term, like if a node send a message, so what we say in this framework, they say it like it actually subscribe to a topic, because topic is a combination, a bus of messages. So when I want to subscribe to some messages, I should subscribe to a topic that is a combination of the messages. It's just a term, logical term one can say. And services. So I have described the services. So can anybody describe what's the difference between message and service? Should I ask?
Service has a response. Message doesn't have a response.
Yeah. So one can say it's a one-way communication or two-way communication. Can I say this thing in this case? Yes, definitely I can say this thing, because messages are, I'm sending the messages, and in the service I want the reply. Like I send a request and I'm expecting some reply. So it's like, it's a perspective you can take that thing as one way as well. So here's a clear picture, like what happens. Like there is some node which wants to send some message. So as I told you, combination of message is the topic. So other nodes will subscribe to that node for that information. Whereas in the service case, a node sends a service invocation, like I need this thing. Like it has some service, like counting some number of people or something like that. So that node is providing some service. So it will ask for that service. In response, it will get like some number, like floating number, like or something like that. So here the messages is one-to-N communication. So you can send like messages to so many people. But once I ask the question, I want, like if I'm pointing to someone, so I want him to answer that question, right? So it's like one-to-one communication. So we send the request and we wait for the. So that was like the basic logical things which you encounter mostly once you read this thing. And because there are so many packages, it's a good news as well as there are so many people have developed so many things. But the problematic thing is that like you can't go into each package and understand that thing. You just have to take the gist of it, like what is being implemented there. So if you know these terminologies, mostly people work on these terminologies. So you can get a basic idea, okay, he used this packages, so he built only this chunk of code. But if you don't know like what the framework is, so you won't get, like, might be you are looking into the hardware code which is already provided by ROS. So that person at that company have written anything for that. So after moving from that, how the installation and like how we can install that thing and set up that thing. This is just for you to see like how we can, but I will give you a demonstration of it as well, like how you can install it on your PC or laptop as you want. So for the concepts, logical concepts, there are some commands as well, which you can, of course, can work with to navigate through that file system. So the first one is ROS Pack. So what idea you get like ROS Pack, what can be? No, my question is like ROS Pack, like, yes, you can read it, but ROS Pack is like describing like this. ROS is just a term which is used, you can see in these three highlighted things. So this is a convention, ROS is being used. Pack means I want some package kind of a thing, right? So pack means it's derived from package. So from ROS Pack is just a command which can tell you like that package depends upon these dependencies. So it provides you that information about that package. Or you can find that package as well, like is it present in my system or not. So that provide like information about the package. What about ROS CD? How many of you have used Ubuntu before? Linux. So they and in ROS, what about ROS?
CD.
Yeah, there is a command CD.
DIR for the Windows.
Yeah, but DIR tells you directories, but CD actually, yep.
You can call a directory or go into a folder.
Yes. So what happens here, like they have made a lot of packages, so it's very difficult for me to remember every package path. So what you will do, like someone told me that there is a package called like Turtlebot Setup, let's say. So I don't know where physically that is present. So what I will do is that I will write ROS CD, the package name, and it will go into that package wherever it will be. So it's kind of indexing, it can go into that with this command. And ROS ls is a listing command, like it will list you how many directories are there in that package. So it's basically navigation, like how you can navigate in your file system. Then the question comes like how you can create your own packages. Like so many people are developing, so how one can create. So there's a command called ROS create package. So that is the first one. So from that you can actually create a package. And the good thing is that you don't have to like manually give like this is my link, this. So you use this command, and in this command if you tell like I'm dependent upon the package of getting data from wheels, so just put the name of that package and it will get it for you. So you don't have to worry about like how I can include that package or how I will include that library into it. So you will just write ROS create package and its dependencies, and it will give you the all that information about that. So basic command is like ROS create package. So this is a command, then you write your package name and some dependencies like my package is going to be dependent upon this. Once you do this thing, of course, like it's a software, so it doesn't know like where you have created your package. So you have to tell ROS as well, or some like filing system like I have created this thing. So there is an environmental variable which you update, like if I have made one package PA, so I will inform the main file system like I have created. So if I made, this is my. So if I make one package and if I want to tell the main system like this is the package, so I will just use this variable and give the path of that package. Right? That package will be included in the searching list, like this is the packages which are there in the main file system. So we can see from the command of ls, we can see the contents, like what is there in the package, like the include files, some source file. Like source file is like where you write your programs. So it will like create a directory for you, and you can write your programs in that. And there are some contents which are not there, but I will touch these things, like how you can actually define your own messages rather than the messages which are there in the ROS as well. So this is about like once I am dependent upon something, so I have to like there's a file I initially set in the manifest.xml. You have the information of like what is this dependency. So if you open that thing, cat is a command in Ubuntu that can show you the contents of the file. So you can see like here some package XLB like turtlesim here, that is a package that is dependent upon like some WX widget library. So once you make your package for the dependencies, then you have to install the dependencies as well. So there is one command that can install those things, that is called ROS dependency install turtlesim. So there is like how you can make your package. So I will give the description in my demo. So this is just for you to look once you are in your home, and you can look it again and again, like how you can create a package. So the summary is like I've touched ROS pack. ROS tag is same, like you can navigate into that and get the information of the stack. ROS CD, ROS ls, ROS dependencies. And ROS make is like once you make the package, like you have to run this ROS make command to compile that program or package. So this again is information about nodes, and let's say like we have in this framework a library called ROS-Py, that is a Python library. So whenever I want to write something in C++, so I have to include this dependency of ROS CTT. And if I'm comfortable with Python, so I have to include the dependency called ROS-Py. And ROS core is another command in this, which, if you remember previously, there's a red node. So that is a master node. So ROS core actually runs that master node. And you can, in your system, you can see like how many nodes are there by typing ROS node -list. And rosrun is like once I make a package, I have to run that node as well. So I write the program, I compile it with ROS make. Once I compile it, it is kind of executable. So in Windows, I can double click and I can run. But here you have to use this command rosrun, and you will write this rosrun, the name of the node, and it will execute that thing. So the basic like the way is like you write rosrun, then the package name, and then the name of that node. So the example here is like rosrun, the last line rosrun, and turtlesim underscore node. So can anybody tell me what turtlesim is here? It's a package name, yes. And if you lost some, like if you have some question, you can ask me, because like if you know this concept, then it's very like easy for you to go like on weekends and just write things down. So rosrun is like the command name. Turtlesim is like this package name, and then I said like it's a node. Node is like the executable in that package. So I write a command rosrun, package name, and then I said like this is executable in there. So I just write those things in one line, and that's this thing. So the view here is like we have ROS code that will run the master, and then a ROS node that will actually tell us information about the node itself, and then the run command, which is basically running that node. So it's again about topics like how we can run it, like look how many topics are there in the system. Like if I have run some program and I want to see like how the messages are being passed between nodes. So what is a way of seeing that thing? Like let's say like I run some program which is built by someone and I want to see like how the two nodes communicate with each other. So there is a command called ROS Topic. ROS Topic, if I put list to that, it will provide me the list of the whole thing which the messages are being passed between different nodes. And if I want to see specifically like what that message is, then I will write like ROS Topic echo that message name. Like let's say in the last line I have some command underscore velocity. This is a topic which is being sent on the network. So I want to see what are its contents are. So I will write ROS Topic echo means tell me what information is, and it will tell me like this command velocity is sending this data. So here again, like I have two nodes and I am sending a topic command velocity to the main turtlesim node, the middle one, and it is then again sending some messages to some other nodes. So this is about again the ROS messages. So then the question comes like, do I always need this package thing to send some message to some node? No, there are some other ways as well. Like you can just write one information. Like let's say like I have written some program and it becomes hard due to one information which is not being provided by some other nodes to it. So I can manually feed it, or there is some other node which can manually feed that thing. So the command is like I will write ROS Topic. PD is the publish this thing, and publish -1 is to send it to this specific topic name. The topic name is command underscore velocity. And then the command is like 2 and 1 minus 8. So when I talk about velocity, there can be two velocities, linear and angular. So that's why there are two values. But the basic aim of this thing is like you can, if there is some topics, you can actually send the information to all the nodes by writing this thing. Like, let's say I have a turtlebot. If I have a robot, I want to send some velocity commands to it. So I can write on a terminal, simple terminal, like how one can do this thing by just writing this publish command, and it will publish the velocities. Same about services. You can see like what are the services which are being running in the system. So I talk about node. So what is node? Question. What is node? I talk about there are some nodes. They are communicating with each other. So what is node?
Different functions.
Yeah, it's a program, so it's not a function. Like in that program, there can be multiple functions. So when I say like all of you are node and I'm also a node, let's say. So I have a lot of functionality, right? So this is not simple function. This can be a very big program or a big package or something like that. So if I want to run multiple nodes, then there is a command called roslaunch. So launch will actually launch all the nodes. If I have written like 10 different packages and if I want to run them collectively, then I will write this thing. And so why I need this thing? Let's say like why I need let's say ROS launch. Let's say I have this PC and it is connected to different sensors like wheel sensor, camera sensor, and I have package for each sensor. What that package is doing, it's actually collecting the data. One is collecting the data from camera, the other is collecting the data from the wheel, right? And there is another node which is getting this information and processing it. So eventually I have 3 nodes, one for camera, one for. So when I have to execute this thing, I have to run these 3 nodes simultaneously. If I run the sensor collection data thing and I don't write this information gathering thing in the back, which decides, there's no use of writing those two packages. And why they make it like this, like I can make one program, the question can be like, I can write one program, and in that program I can write like, get the data from sensor, get this thing from that thing, and do it. But the problem is that once you write everything in that, so that becomes sequential. Or you need some parallel system. So in this case, I can run my data collection distributedly far away, and I can collect the data from some node which is like present far away from the one which is collecting the data. So this is the script you have to write. Like here you start with launch, and you provide like this group NS. NS means this is the group of some nodes. And then you provide the name of the node package in that. Like package name is turtlesim, and then this name is alias, like you can give some alias to that, like it's same. And the type is like the name of the node. So I provide the information like this is my package, this is my executable. So I have multiple packages, multiple programs, multiple executables, so I write those things in this script. And one thing is that like you don't have to remember this thing, how this script works, you can just copy paste it and just write your packages in that once you made it. So now comes like the simulator thing. I think like the basic, I see some faces like it becomes like a dry thing, because those commands are dry because they just provide you information. So I'm not talking about the programming thing, which is the main thing. So this is like a one-day thing. You just remember those things, and you can easily traverse between different directories. But the core thing is like how you will going to program the thing. So you don't care like where this folder is. You have one command and you can move into that. And if you want to see like if I have written some program and sending some information, you can use that command. But the main thing is how you write that specific node. And let's say like if I have a report that can give me information and I can manipulate on top of that. Like in our case we have a report, it will give me information. But what about if you want to simulate a data? Let's say like if I want to simulate a data of camera, like how camera will provide me the images. So with simulator you can do everything, but that is just in simulation, that is not real. So it's cost effective. If you don't have a report, you can do this thing. Time wise, you can do it in parallel, no problem of battery charging and stuff like that. And experimental, of course, you can do those experiments repeatedly because you're not caring about like the physical hardware that can be damaged. So here they provide like more than six actually simulators which simulate the information for you. Like on the left top you can see that Gazebo. This Gazebo actually provides you 2D information. Like if your robot is working in a plane, XY, so it will provide you information of, let's say, the wheel and like the camera thing. Whereas like if you move to like the 3D, then you, of course, from 2D plane to 3D, you need some more information. Then there's another simulator for that as well. Let's come to Kinect. Like this is also introduction what Kinect is. Kinect is basically made by companies like Reinvent and Microsoft. And Openni is a driver. Like they provide you, they collect the data. Like you don't care about how I can collect the data from that hardware. So Openni actually provides you two things. One is the image, and the other thing is depth. So you can see here as well, like one color image and one is display. So you can install this thing by writing this command like sudo apt-get install ROS Electric Openni driver, and it will suddenly, once you install this driver, it will and run this thing, it will send you the messages. Messages are like color images and these depth images. So you can display those things. There are commands as well, like image view, you can display those images. and you can then manipulate with those images as well. So the advantage of this driver is that like you don't have to use some, you don't have to write the code by yourself for that driver, and it gives you some register data. So it gives you register data of color against the depth. So if I want to move in this room, let's say, so what kind of information I'm using? I'm using information like how far the objects are from me, right? And sometimes I can use color information as well, like if I want to go to one specific person, let's say if I want to recognize something, then depth is like, depth can be used, but color is more information to me, like I can easily narrow down that thing. So in this case, they are providing the two registered things, like it's not coming out of sync, they are synced together. So if I want to use this information in some robotic thing, so I can just zoom into that narrow down color thing, and then using the depth information, I can navigate to that place. So this is like the CCNY. This is how like they show like they can actually get the data of Kinect, the color image, and then the depth image. And then once you want to see the depth image, you can see like where those background is, where the foreground is, and then you can of course manipulate that thing as well. This is one of the visualization thing in which you can visualize the point clouds, you can visualize the images. That is called ROS, and it provides a lot of information about this. So better thing is that like you have this pointer and you can go and see like how this works. But the basic thing is that it's a 3D visualization tool which gives you information about 3D kind of visualization. So now coming back to like that was ROS. Now coming back to the real project, because that was like kind of a theoretical thing, but this is a real thing. So we have this Turtlebot, and what it has got? So it has got a Kinect that is D. So it's a 3D sensor. It will be providing me the color image and the depth image, right? And on the bottom there is this called A thing. This is like off-the-shelf hardware, they call it iRobot, and it provides me like the information of the wheel, like how much I have moved. They call it odometry, and the direction, that is gyro. So I can get like XY position and then the direction out of it. Then there is a laptop on top of it where you will run this ROS framework and with your packages, and this is a basic structure, so it's a very fragile thing, and I have like the instructions as well, like how you are going to use that thing. So maybe you have seen this thing. This is just their intro, how ROS works, or what can you do with this thing. So as I told you, like it has like XY information, like where, how much translation is it getting, and in which direction it is moving. So you can use that information with plus this color depth and image, and you can navigate through some buildings. So in this case, if you see this thing, this is like a kind of a laser data or a depth data. So using that depth data, it can navigate. There is like this skeleton recognition program as well. You can recognize your skeletons. And of course, you can get some tea, coffee, beer, whatever you want. And behind the scenes, this is like behind the scenes there is this flow as well, in which they are sensing something, planning something, and then acting by moving that sensor. So like the handling section, so this is quite important because the problem with here is our room space where we are going to run this Turtlebot project is very small. So you have to be very, very careful because this Turtlebot is very fragile. And other thing is that like whenever you like try to move this thing, try to make a space for that, and so that you won't damage anything. And we are going to make a project leader in that as well. So he is going to look after like what damages has been done. And in the programming, so I will discuss the programming as well. There's this void of code recorded. It's like exceptional handling. So if you get information like your robot is hitting something, you can stop it. So here in this Turtlebot, there is one sensor which gives you this information, like this Korean thing. So you can subscribe to that, actually the message, and you can read that message. And if it says to you like, okay, I'm hitting something, you can stop. You can send a command to stop that thing. So this is again like the basic structure is like we have a workstation and this master Turtlebot. So I called it master because this will be running all this collection thing, and this will be communicating with other, like can be a workstation, can be a laptop. So the master will be collecting the data, and what kind of a data it will be collecting from the Turtlebot? Can anyone answer? It's just a wake-up call actually, it's not like, yeah. So what kind of sensor Turtlebot is providing? Like, you can see and tell me like what kind of a sensor which I have discussed. Yeah.
Depth and color.
Sorry?
Depth and color.
Depth and color. Then I talk about like its base. It gives us the x and y as well. Like if I move in x direction, let's say this is my x, because this I have this 2D plane. If I move in this x direction, it will provide me some incremental information like you have moved 1 meter, and in the y direction as well. And what about my because this is position information, right? X, Y position. Then there is another information which is coming from gyro, which is telling me my orientation. Right? So it's X, Y, and orientation, because what this robot is operating in 2D plane, not in 3D. So it's not, it don't require X, Y, Z, roll, pitch, yaw. Only requires the yaw angle, the orientation, and this X, Y. So this master will be collecting all the data, and it will be sending back to this remote, like this laptop. But you can't write the program on this laptop because this has to be like where you can't actually access that thing. You can't take it out. And so there's a like remote login. So you can log in remotely from a workstation, which is there with the tutors in the first labs will provide information about. And you can use your own laptop as well. That will become handy. Like I encourage you to use your own laptop, install Ubuntu if you can, and like if you have problems, let us know. And if you install your own this ROS thing on your laptop, you can take your Turtlebot out of that lab space and you can do your experiments. So this is the setup procedure. For the master, I have to give, because this is connected on a network. So I have to give the IP of that, like where is my master. So for master, there is an IP, so I have to give that IP. And for the workstation, I call it host name. So I will provide the IP for that host name. So this is like Turtlebot Setup will declare master and host. And as it is master, so it is a host of itself as well. Whereas the workstation actually is only a host, it's not a master. So once you see in this, like once you go into these lines, you will see like this workstation setup will actually give a pointer of master to that Turtlebot laptop. So as I told you, like there is a SSH command, so you can remotely access that thing. And I believe the tutors will tell you in the first labs, or you can actually look into this. Like SSH is a command. Turtlebot here is the name of the user, and then at the rate means IP. So I will give, I can give from here. I can give a IP. If I know some IP, I can log into this computer. So same concept here. Like from workstation, you will be remotely logging into that laptop, which is placed underneath like some of the bars in that Turtlebot. So I can remotely check like what is the health of my robot, like what is the battery, what is like battery means like this Turtlebot has its own battery for moving this thing. powering this Kinect thing, whereas there's a laptop, it also has got battery. So there's two informations coming here on the bottom, like there's one is for laptop and one is for the sensors. And you can change the configuration as well, like in this dashboard thing, this is one app as well. And the Turtlebot teleoperation is just a package written by someone. And in your first project, what you are going to do is that this package is already there, right? But I'm going to discuss that package as well, like what is there inside that. So you have to extend this teleoperation thing. Teleoperation thing is that like there is a Turtlebot from the keyboard of the laptop, that is a workstation. I will send some commands to that Turtlebot, and it will move accordingly. If I press forward, it will move forward. If I press left, it will move left. So from that teleoperation, you will actually be controlling this Turtlebot, this robot from the workstation. And the project is you have to extend that teleoperation. So this is just a basic thing, like once you need to install like ROS Electric, you can go on the website, Google, you can run this thing. So there are multiple platforms which you can use for the installation. You can use, because we are recommending Ubuntu, so I went to Ubuntu. And just here in this case, there are some distributions. And I have this Mackie version. So this is just a procedure, like you just have to copy it, and this black thing is terminal. So once you write this thing into that, you actually are installing like a Windows, you're installing something, and that is actually a framework. It provides you everything. So you will copy this thing, you will copy this as well. And this is finally like, it contains a lot of packages. So I will show you here as well, like what these packages look like. So if you put static here, you can install all the packages which are available in this ROS distribution. You have to press enter. Of course, I have this installation, so I didn't actually. Then I have to tell the system as well, like where this is placed. So this is one command, so I will copy this thing, like my ROS source has this path. So bash HRC is like, whenever I open the terminal look into some environmental variables. So now I define something like an environmental variable like this is ROS, so I can access that software pack, like framework from there. And on the hard disk, you can check like there is this ROS folder which contains a lot of packages. Like these are packages, these are not only folders, and there is some navigation thing. Like the demos which you have seen, you can just run one of the package and you can replicate that thing. In the videos that looks very fascinating, but once you have to do this thing, you have to go through all these things which might look boring to you. But like you can just run one of the package on Turtlebot and you can see some like moving in the building, and like you can easily do this thing. In the lab you can go and you can manually move the board and can make a map of that like that lab. And then in the second there is a package which will use that manually moved map and will execute that report accordingly. It will know like there is this obstacle. So if I feed that map, it can move around that. So those packages are already there. So let me move to the next one. Is like this is the simulator which I was talking about. It's called Gazebo. I will provide the videos to you. You can look into that. So this simulator is like a real report. Like it will provide you all those information. Once you send the information back to it, it will like move like that. So here I am just putting some obstacles around it, and I want this actually board by manually controlling it, that it can move through these obstacles. So what I will do is that I will run a program that will tally up, like I will use my keyboard and that will send some commands and I can move through it. So I just write roslaunch, turtlebot, tally up keyboard. So now it's telling me like if I press U, it will go left, there's I, J, K, and with that I can move. And here I can see some of the images of this simulated data as well, like all the images look like, just for manual inspection. So here what I'm seeing is that like what kind of a message I have to actually subscribe to. So this is a message like image underscore ROS, so I actually subscribe to that thing and it showed me like how it is being placed among those obstacles. Then I press from my keyboard and it moved among those obstacles. And this is what we like. I have simulated another thing like we don't want you to do that with a real board. Like if you find an obstacle, just stop that thing. If you try to hit that thing, of course something will happen. So this is what is happening. Like I'm just hitting that thing again and again. In simulation you can do it. In reality you can't. So you see, like you have the physical robot doing everything in that. You can actually move that robot wherever you want. So these are only the two applications. So the first project is like 5 marks. So you have to extend this project, and once I press forward, it should move forward. Like here what happens, I press forward, it moves forward and stops. Right? Then I press forward, it moves forward and then it stops. Right? So what we want you guys is just go through this thing. It's just a warm-up project, easy 5 marks. Go through that thing and extend it so that it keeps on moving. Like if it is moving around like in circle, it keep on moving in that circle. Right? So there is like one line actually you have to change. So yeah. And then there are 3 extra marks for the second project, in which what you have to do is you have to move in a square. But in that square there is an obstacle as well. So that will get like 8 marks. So but the thing is that with this you will know like how to move forward, left, right. So you will find actually a combination, like if I send this command 10 times, I can move 10 steps forward. Then on left, if I send this command, I can move left as well. So by sending those commands, you will ask the robot to move in a square, kind of a square. But the extra thing is that you have to sense one sensor, that is like a clip sensor on top of Turtlebot. So it will tell you once it collides with some obstacle, it will tell you like 1, let's say. So once you find the obstacle, you have to avoid that obstacle. You have to have some path for that. This is an example like how you can make your own package, and the package is the same which I used previously, like this tally op thing. So you can make this from scratch. Of course, previously I used that package, but now you can actually replicate that thing. You can make your own package. Then you can edit the source file as well, like what the source file is and how it looks like. And in that editing, you will need to know like what kind of data it is publishing, like what kind of a data it is sending to the robot to move, like velocity commands, what those commands are. Then I will look into like compiling that program, then like setting ROS package path. So this is a basic demo as well, like where you can actually, by a simple command like this, you can make your own package. Here the package name is my tally, and these two geometry messages are some dependencies which I am telling to ROS, like these are some dependencies which I can use in this package. So here I'm just writing this command, it has made this tally of package. But it's telling me like I don't have the path of this new package in my ROS directory, so I have to add this path into the ROS directory. The same things which I actually told you previously will be here. So just and going on the hard disk and seeing like where this is being created. So the package looks like this, but when I go into the source file, unfortunately this source file is empty, like there is nothing in that. So this is just empty folder. So how we can actually create the source file? We can use that source file which is already there in the ROS system. So what I'm going to do is I'm going to find the package which has got the source file, and I will copy that source file into my directory. So in this line I am just giving a path, that is like I told you previously, ROS package underscore path, and just giving it like where the new folder is. Now if I want to find ROS pack find, so it will tell me like this is the path of the folder. Now ROS recognizes this thing. So just to check like this package depends upon which things. So it is telling me like it is depending on some package called geometry messages and ROS CPP, because I have to write some C code in that. In fact, it is like these are just the dependencies, like these three dependencies are what I have given. In fact, it's actually relying on 17 to 18 dependencies. You can see that as well, but you don't have to be careful about that, because you just have to provide extra dependencies which you have yourself included. In this case, I have included CPP, ROS CPP, because I have to use C++. And another, I have used some geometry messages, because here I'm going to use the keyboard thing, and those things are defined in that package. So that is why I included that thing. So now what I'm doing here is that I know like there is a package already in the ROS directory, but I don't know like where it is. So I just write its name like turtlebot Setup. I went to its source directory to see like what is there. So there are two CPP files which are like the source files which are executing that thing. So currently what I'm doing is that there is already a package, so I'm just copying that source file into my package just to compile it, like to see like how I can create a package, how can I compile it, how I can run it. I'm just giving the path, like here's the path of, there I get error because I haven't given the space, and so what you are getting out of it, like where we can use this whole system, like once we have this, once you make this package, let's say, which is already there, if I want to modify it, what will I need? If I want to modify this package, a package is being created, right? So then I have to play only with that source file. This thing is gone, like this whole procedure of like making a package, giving it dependencies. I just have to, like if I go into the source directly, you can see like there is this file. So ROS make is like the compilation thing, it's compiling that program. So it has made this bin thing, and if you, so it compiles correctly, but when I go to the bin to find some exe, there is no exe. So there is something missing still. So what that thing is, like there is some this make list where you have to manually add it, like make a exe as well. Otherwise it will only compile that C++ program for you, and it won't make an exe or node in this case. term here which is being used is node, but it's exec. So by writing some manual command like make an executable in the ROS build, so we'll make executable for that. But with this, you're actually going to start from here onward, actually, not from like learning what ROS is, how to make a package. So you're going to start from that source file which I provided, and you will change that source file and recompile it again. Right? And the whole procedure is same. But what you have to do, you have to fulfill the requirements like it has to move in like forward direction and it has to move in the forward direction until it is being stopped first.
Are these files on the site, on the website?
This is on the, not on the our website, it is on the YouTube. So I have provided my link, so you can go there and download this.
But your slides are the slides. Can we see the slides? Like,
yeah, I will email all of you. So that is why like I just gave you like the overview, so you can go and actually read those things. Problem is that like if you go to this ROS website as well, the information is spread out. Like you won't find this like this kind of a presentation as well. So I will actually email you guys as well, and I might put it on the wiki of ROS as well for further people, for other guys who can use this thing. And the all this thing is like just basic theme. You can go to the ROS tutorials as well, and it describes everything in a written form as well. And then I try to run this thing, and it is complaining about something. The red line is showing me like I have run the executable, but I haven't run any master to it. So it expects some main central node to be run before running this thing. So this is like I made the same thing from scratch and like copying the source file, and I can do the same things which I did before. But here the commands are like arrow commands, where in the previous one it was like IZK, something like that. So of course you can move it. So if I want to see like what this simulator is, like what kind of information it is sending, so these are the topics which it is sending to me. Like it is sending some, if you can quickly see like order, it's about ordermetry XY information. TFS is like transformations. Might be able to read it like in some future lectures. So you will have this thing. And let's talk a little bit about OpenCV. Like OpenCV is also basically overtaken by Willow Garage, so they are actually looking after this, and ROS is also there. So you can do a lot of many things like segmentation, transform. So these all chunk of codes are there. So you have to use those chunk of codes in your ongoing projects. So how I'm going to actually use this image processing like library, the OpenCV. So what happens is that like here the concept is of messages, that is like quite strange. Whereas in OpenCV they actually expect like some image or data matrix. So they write a wrapper function. They call it like this CV_bridge. So it wraps that message back to the image. Once it is back to the image, you can apply all those image processing functions on top of those messages. And this image geometry actually helps you to do calibration. And I placed some code just for you guys. Like here I am just subscribing our topic on the line 14. I am subscribing to image topic
So it will give me an image, right? A matrix like n by n matrix for 60 cross 640 kind of a thing. So once I get this image matrix, so then I can use all those functions. If someone has used Openni, I can use all those functions and I can get some information out of it, and then can get some results like if I can see the red color in that or not. So I can use Openni in that and just get the results of that image. So I can of course I can send some images as well to some other nodes. So here's that code which is doing that thing. So those are the images. Like what about like 3D? Like the world is not 2D, so we won't actually work in XY. We actually work in XYZ. So for that, actually, the first image tells you like if you on the left, if you want to match like two objects by only 2D information, you can't get it because there can be some color information loss or something like that. But if you use the 3D information, like how that geometry of that thing will look like, you can of course use that 3D information into that. For that 3D, there is like Turtlebot, we have this Kinect. I showed you the data before. So you can use that 3D information. For 2D, you can use Openni, and if you want to use 3D, there is another library, they call it PCL. So again, in this PCL library, everything is being done. Like they give you the segmentation thing. Like if you remember, you have seen in demos recognition of some things. So the codes are here. You just have to plug that code into your program. And like the problem is like this integration. Like you might have to put some effort for integrating that thing. But once you integrate that thing, you can do some registration, like recognizing something, and you can do some filtering. You can actually do some like segmentation. Like if I ask you to find out like a laptop on this table, you can do it by using this library. You don't have to need the knowledge of like what is happening inside. You just are using a black box which is being provided by PCL. Of course, you can go into that code and change that code as well. So this is just an example. Like this is a table where there are some cups and glasses. So these guys extensively are using this thing because like they have PR2 robots, so they have to actually interact with the environment quite often. So they use these libraries to make their robots quite easy. So this is like again like I discussed Openni before, like a driver for Kinect. So that driver is providing me this color image and this 3D data, and this 3D data is actually a message. So here again, like I have to convert that message into the format which is like readable to PCL. So there is just this. So why I put these wrapper functions? So once you have these wrapper functions, if you know that library or functions of that, by using only this chunk of code, you can actually integrate that thing. So this is basically integration code where which took a lot of time guys to integrate. But once you have this message conversion into the format with PCL points, you can use all those functions with PCL as. So I'm not going through this code, but you can easily see like on the left I have declared some point cloud thing. It's a message actually. If you go through the line 15 on the left, there I define like sensor underscore message, so point cloud, and then I convert that point cloud to a PCL readable format, and then I can apply. There are some functions. So what this code basically is doing, it's actually segmenting the thing. So it will be doing the same thing which previously we have seen, the segment of some objects. So it's up to you, like if in the final project, if you want to recognize something, you can use a simple 2D image. You can use this 3D point cloud as well. So there are actually two tasks which we talked about, like this extension of Telio. And then there is a final project is like how we can use all the information which is given by a robot like this autometry, this 3D information, and get out of some kind of a maze and then find some object. So the quick thing is there is like using PCL, you can recognize an object. With OpenCV, you can recognize an object. And with this 3D information, you can see like where the free space is. If someone asks me to move in this environment with closed eyes, I can't actually, right? So I need this 3D information to move among obstacles. So if there is only one door outside, like you have to go, so you have to find that door and you have to move accordingly. So here it's about sensing and the action. So what we have covered, like we have looked into this ROS basic structure and the different packages which it has. And this is like ROS is the link which you can download the videos from. And I will send you this presentation by email as well. So you can like on this coming weekend you can look into the things like which I discussed. So this is just an overview. So you have to look very closely because there are sometimes you can spend a lot of time only on this basic creating a package thing, right? If you see a video, you can create a package, you have the source file. So I won't finish it here, like I will just go through quickly like what the code looks like. So just to be your it will be helpful for you, like if you understand. So now basically for this form project, what you have to do, you have to replicate everything, right? And once you replicate this thing, you will come to this source file. This is being there. Right? So what this source file is doing, it is collecting some data from keyboard and sending some information to the turtlebot. And you don't have to worry like how it is collecting the data from keyboard. That's not your worry. How it is sending the data to the turtlebot, that's not your worry. The worry is like just a logarithmic thing, like how you can make that thing work continuously. Like it's sends and stops. So just a quick look, like so I just copy this thing. So here the key codes are like the up, down, left, right thing, right? So we basically ask you to change these to I, J, K. You can replace these variables with I, J, K, L, like the characters. Basically, I define a class. So how many of you have worked on C++? Okay, right. So basically, you have to. There is some links on the internet where you can see easily. And what about Python? Does anyone work on Python? Okay. Python is easy, but that's difficult. So C and C++, that will be a question mark. But here what you have to do is that like I can give you the overview of this thing, and I can tell you like which function you look into, right? That is the most easiest thing I can do. And you just have to change that thing. So what we are doing here, I'm defining some class. You don't have to worry because you don't have to define a class. Then I'm defining like some functions in that, like void job. I told you previously, it's like a code which is like exception handling thing, like it is handling some exception. So there are some bunch of variables. You don't need to worry about those as well. This function is basically my startup function, and they call it constructor. So this is the first thing which is being called. So what it is doing, it is actually like here pi, linear, angular. It is actually declaring, like giving values to some of the variables which I declared previously. So what linear, angular, L scale, A scale is, I will tell you like what these are. And but here I am doing, like I told you previously, in ROS structure they have this parameter thing. So I am defining that variable as a parameter as well, so that I can send that parameter as a message, right? So I define those variables here. I have declaration before. I just put the values there. I converted those A scale value and L scale value to some parameter that is like the format of ROS. And here I am publishing, what I am publishing some command of velocities. So I am sending a linear velocity and angular velocity. So when I give a linear velocity, what will happen to the robot? Can anybody tell me that? Yeah, it can move forward and backward, right? Yes, it can't actually move like that. Right? So for that, you have to give some angle to that. So what we have, like we talked about, like x, y, and z. X, y is like you can move in this direction, this is x, and of course, like if you are here, you can move like this. But if I want to change my direction, I have to give some angular angle to that. So what is happening here is that like I am defining some linear and angular variables which actually tell like the robot like which kind of velocity it has to take. And the scale is like what is the magnitude of that. Like I want to move this thing 10 steps, let's say. So I want like this scale should be like 2 or 3. If I want more magnitude, more movement of that in that direction, I will give more magnitude or more speed to that. Because here the velocity will increase its speed and distance as well. So you know this thing like by putting the values to this thing, you can move your board forward, backward, left, right. So you can come up with a combination of some like values which can make this board move in square, right? You can come up with an idea in which it can move continuously or what. So here I am just publishing this thing like advertising like okay I have this information. Advertising means I'm sending it to someone who is receiving, who is looking for this message. And who is that? That is Turtlebot actually. This is application which is sending some velocity commands, and Turtlebot is actually looking to that command like what kind of velocities I'm getting. So this is a good thing that happens at the end, so you don't have to look into this function as well. And this is in C++ at the start, and the constructor is like once you define some class, then it is being called. So here what I'm doing is that like I'm initializing the ROS in it and defining some like class variables. The signal thing is that like if I press Control C or when I want to finish this thing, then I should know like I have finished. Here I define thread, you don't have to worry about this thing as well. A timer is actually looks to this thread again and again, and I just have given some value to that thing as well, and the spin. So this is a watchdog thing. Like watchdog is what it is doing is that you are actually going to send some commands from the keyboard, and it is like after certain time it will ask the Turtlebot to stop, right? So here is a mystery, right? So it is stopping that Turtlebot. And in your first project, you have to stop that thing only when you press something, or you are struck by some object. So this is a function to look into, right? Because this is the one which is stopping the robot to move after a certain time. So let's say if I delete this line, what line? This publish 0, 0. Publish 0, 0 means send linear velocity to 0, angular velocity to 0. So what will happen? It won't move. If I delete this thing, you have to stop the board by taking that thing. Right? So don't do that thing, but just make a program that actually you have another key as well to stop that. Otherwise, you have to run behind it and have to grab that thing and then have to unplug that thing or power off that thing. Right?
How fast does it go?
It can go very fast. I can show you here as well, like on the simulator, it can do a lot many things. So yeah, you have to be careful, very careful. Like once you move that thing, you will get excited because this thing like is the main thing behind every success, like people move those things. But like once you move those things, you will really get excited by using the packages which are there. And once you make your own programs, definitely, I will guarantee you that you. The messy thing is like you have to develop everything, right? But once you get the output, if you are not happy, the people will definitely be happy. Like once you move the board, ways or something like that. Okay, so this is the function which I told, like this watchdog, you have to work on this function. A key loop is just a main function which is getting the data from the keyboard. So again, like you don't have to write a messy code like what the keyboard is, just a function like this is like a function t get tr. So what it is doing, it is just collecting the data from the keyboard, and here it is. This is basically ROS main function. So here this is a switch. So here it is telling like move left, move right, move up, down means the other direction. So I told you like you have to change the keys as well. So only this block is also very important. Just to look into that and change the keys to the ones which are being asked. So the basic thing is that like if I give angular variable 1, right? So it will give the velocity in angular direction. So when I say left means if it's standing like this, it can move left and right. So this is angle, right? Up and down means if I move this thing like here, then I can move in this direction. Okay? I can't move in this direction. I have to move this way, and then I have to go in this direction. And this function is again like nothing important here. The main thing which is important is like this thing. Start is very important and in between, right? Because here if you see closely, here again I am putting values to 0. Right? I want the robot to move continuously. Surely I don't have to put 0 again. Okay, so here I am just publishing this thing. A scale and L scale, if you want to increase your angular velocity, if you want to increase your speed, you have to increase this variable as well, right? A scale means +1, +2, -1, -2, that will decrease it. And same goes to the linear scale. So this is the basic program which will help you in both of the warm-up projects. One to move it in a scale, and the other one is like using this thing without like until you press a key, then it will stop. So this is the code. You have to amend that thing. If you want, I can show you like how this in a simulator how fast it can run like this robot or what can it do. But it's really good like if you just take this presentation, take this video, try it yourself, and see what comes up. And on Monday there will be like 2 tutors, Deep and How. So they will actually guide you all those procedures again. Any question? Or you get bored about this timeline? Right. So that's the end. Like I can send you like the presentation, and thank you so much for your patience listening.